So welcome to this unit one, thermodynamics unit one, which is introduction part. So I'm taking the first question. So generally, I am doing 10 to 12 questions, important questions in the unit, so that a student can understand the basics knowledge of this subject here in my channel. So try to understand this and take a note of it and draw the diagrams. You can pause it and you can get a knowledge, a better knowledge in this my video. So let me take the first video. First question, that is, what is the difference of microscopic and macroscopic? So generally, microscopic approach considers the behavior of every molecule by using statistical methods. So here you are having statistical methods. So what is the meaning of statistical methods? Is we can prove itself by using the mathematics. So in the macroscopic approach, we are considered here what is happening with the gross or average effect of many molecules. So many molecules. This is molecules in a vessel you are taking one. Gas molecules are there. So if you are taking one molecule and you are studying about that, then it is a microscopic. If you are taking 2 to 3 or 3 to 4 molecules and studying about their average, about their pressures, temperatures, then it is called as macroscopic. So you can see here the lid is given. All the molecules are randomly hitting with each other. They are hitting with the walls of this container and continuously moving. But here the lid is on the top. Here the second position, the lid is coming down and putting pressure on this molecules. They are also trying to lift this liquid lid upwards. So this creates some pressure and temperatures in this liquid. Okay, it can be sensed and can be measured with the instruments. So you can by seeing or by touching physically, you can say that some temperature and pressure, or by using some instruments also you can say that you can test the pressure and temperature. Examples for the microscopic will be kinetic energy and impulse force. What are the macroscopic means? They are giving impulse kinetic energy micro. What is the quasi-static process? This quasi-static process is generally a slow process here. So let me take the definition and let me take the diagram. In thermodynamics, a quasi-static process is a thermodynamic process that happens slowly enough for the system to remain internal thermodynamic. So internally it has to be okay. Internally it has to be process should be taking place slow. Okay. So you can see if I'm taking a gas in this container, okay, what is happening with the molecules inside the gas is moving. They are having they want to lift this lid upwards, but the lid is having some force. Sand is kept here, or weight is kept here, which is putting downwards. So this kind of system is called as the quasi-static system. If studying the system, V is constant, then you are going to study PT. It is called as isophoric. If pressure is kept constant, then studying about V and T is called as isobaric. The third, when temperature is equal to constant, we are studying about these two quantity variables, pressure and olive. So this is called as isothermal process. Adiabatic, so high heat is neither created nor going out, nor coming inside the process. Then it uh, then it is called as this one. Uh, so third question I'm taking, what is point function and path function? In the here we can say point function. This is point function. It is having some P1 value, V1 value. This is having P2 value, P2 value. So it is a point. So it is a point function only. So point function means a variable is taken. A path function you can see here. This path function is 2 points. It is having a starting point and ending point. So it has to travel one path. So here you can see there is a path of R, path of Q, path of R, P. So any one path it has to follow because this is the ending and this is starting. Ending and starting. Again starting and ending. Like this. This will flow. Energy will flow. Here. So let me take the definition. So the path function and point function are introduced to identify the variables of thermodynamics. What is path function? Path function, their magnitudes depend on the path followed during a process as well as the end state. So in the path function, what end states are taken. So what is the point function? They depend on the state only and not on how a system reaches that state. Okay. The examples for the path function are work and heat. So work and heat, they definitely follow up. They do not follow any point function. They are having a path because work is represented by W1 and W2. Heat is represented by Q1 and Q2. This is a very important point you have to remember in your subject point of view. So example for point point, we are having pressures, temperatures, and volume. So they are having a variables. Some volume will be there, some temperature will be there, some pressure will be there. Fourth question, if I'm taking, so what are the ideal gases and real gases? So according to this definition, two types of gases exist. That is real gas and ideal gas. So what is the exactly different definition of this real gas and ideal gas? If you are taking as the particles size of an ideal gas is extremely small. So the particle size, okay, or the atom size is very, very small and mass is having almost zero, no volume. Then it is called as ideal gas. Okay, it is a point mass. The molecules of real gas occupy space. So real gas occupy space, though though they are small particles and also have volume. So they are having volume. So they don't have volume, they have volume. Then they are called as real gases and ideal gases. So you can see here real gases and ideal gases. They have volume, they don't have volume. They have zero mass, almost zero mass, they have some mass. So this is the difference between real gases and ideal gases in thermodynamics. So here also energy lost in collisions. Collisions are elastic, intramolecular forces, no interactions between the particles. Okay. Fifth question, if you are taking, what is meant by zeroth law of thermodynamics? So let me take definition first. After that, I will take the picture, I mean, image to explain. So what is happening, ma? The zeroth law of the thermodynamics states that if two bodies are each in thermal equilibrium with some third body. So say three bodies are taken, ma. So for example, this is having temperature 10 degrees, this is having temperature 10 degrees, this is having temperature. All the system is said to be having temperature of 10 degrees only. Then it is called as zeroth law of thermodynamics. They then they also in equilibrium with each other. This says in sense that the three bodies are all of the same temperature. So three bodies having same temperature. So zeroth law. Zeroth law means they may be temperature is shared. What is meant by Joule's experiment? The sixth question if you are taking. The original Joule's experiment consists of a receptacle filled with water. So this is a receptacle which is filled with water. This liquid is stirred by this stirrer. Then some vibrations are produced in the molecules of the water. So where heat is generated, that heat is read by this thermometer. Pressure rises from T1 to T2, which is recorded by using thermometer here. So here the Joule's experiment is done in this way. So filled with water and a mechanism with spinning plates. So you have to spin the water. This gave an experimental confirmation of the equivalence between heat and power. So in this way, Joule showed that heat is generated by using work. Work is done by using heat. Both are path functions. Both have relations one another. This was explained. Now defined to be exactly 1 calories to every 4.184 joules, called a thermochemical calorie. And what is the heat generated? Q is equal to mass of the water at a constant volume because volume is not changing into temperature T1 minus T2. So this is the Q that is given equation by Joule's experiment by conducting this experiment here. So let us take in the seventh question. What is meant by first law of thermodynamics? So let me take definition after the ultimate. The first law of thermodynamics states that heat is a form of energy. So generally, heat is also a form of energy, and thermodynamic process are therefore subjected to the principle of conservation of energy. So conservation of energy is energy neither created nor generated in the universe. It is already there. Just it will transfer from one form of energy to another form of energy. This means that heat energy cannot be created nor destroyed. This was said by this first law of thermodynamics. So here you are having a cylinder piston which is having some weights on the piston. Now there is a fluid. This black color is atoms and molecules you can see. So once some heat is given to this heat is given to this one, what will happen? This molecules internal energy rises. After that, the piston is moved upwards. Then work is done. So whatever the heat you are giving heat transfer, so what is happen is it is developed in the form of some internal energy E plus work. So Q is equal to E plus Q, E plus W, which is internal energy E is equal to work heat minus work. So heat generated here minus work is equal to internal energy. So this was told by first law of thermodynamics. So let me take the next question. That is eighth question. Limitations of first law of thermodynamics. So the limitations of first law of thermodynamics is that it does not say anything about the direction of heat of flow. So in which direction heat has to flow or work is to done, it is not telling. It is telling that only heat and work, no direction flow. That is the main limitation of the first law of thermodynamics. It does not say anything whether the process is a spontaneous process or not. It is also not talking about the process. The reverse process is not possible here. So reverse process is not possible. So it is one of the limitation here. In actual practice, the heat does not convert completely into work. So the heat is not going to be completely done into work. Some internal energy is taken. So here, higher temperature is there. Here, lower temperature is there. So the heat is always traveling from the higher temperature to this engine or pump. Then it is again traveling to this lower temperature. But the heat cannot flow from the lower temperature to higher temperature, which is wrong. Which is wrong. It is the limitation of this first law of thermodynamics. Generally, in a natural way, it flows from higher temperature to lower temperature. This was the limitation of the first law of thermodynamics. The ninth question, you can see here, ninth question. Ninth question, if I am taking, what is meant by Polaris of perpetual motion machines of first kind? So PMM1, perpetual motion machine. So let me take the definition here. Perpetual motion machine, the machine which violates the law of thermodynamics. So it is not following the law of thermodynamics. What is how it is not following the thermodynamics? A machine which can supply mechanical work continuously without consumption of any energy. Okay, so the mechanical work continuously is converted to energy. Okay, so which violates the first law of thermodynamics. So if total work is converted to total heat energy, or total heat energy is converted to total work, what about internal energy? So it is not satisfying the first law of thermodynamics. So it is violating the law of thermodynamics because it is not explaining about internal energy here. So here work is there. So piston is moving up and down. The gases are entering from here, and the piston is the gases are putting pressure here on the cylinder. So this cylinder is producing some heat energy. This heat energy is transferred to this wheel in the form of mechanical energy. So here work is done. Here heat is generated. Total whatever the heat is given, total work converted to total work. Whatever is there, total converted to heat, and it is not talking about internal energy. So this is a PMM1 model, which is failed model. So 10th question, last question of this unit. Explain about first law applied to flow process and non-flow process. What is flow process and a non-flow process? Let me take the definition mark. An isolated system does not exchange energy with the surroundings in the form of work. So Isolated means it does not have contact with the surroundings. Whatever the heat is inside will remain inside, will not go to environment as well as heat. Work will not go, heat will not go. The first law analysis of the non-flow process. The first law of thermodynamics can be applied to a system to evaluate the changes in its energy when it undergoes a change of state while interacting with its surroundings. So what happens is the first law of thermodynamics can be applied to a system. When it is applied to system, it evaluates a change in the internal energy. So there is a compulsory change in the internal energy when it undergoes a change of state while interacting with its surroundings. It will also interact with the surroundings. The steady flow energy equation SFE, the streams of material crossing the control surface must not change their state or flow rate. So this is the steady flow energy equation. The streams of material crossing the control surfaces. So here control surface is there. It should not cross the control surface. Within that it should be and must not change their state or flow rate. So here nozzle is there, diffuser is there, compressor is there, turbine, throttling devices, boilers, evaporators, condensers, water turbines, water pumps. These are all our control systems only. Ma. So you can see this is a nozzle ma here. This is a turbine ma. So this is a big area, here small area. Here small area and this is big area turbine ma. This is a nozzle. So increasing the velocity, decreasing the velocity. Okay. This is turbine having one inlet, one and outlet here. So this is I think compressor ma. Two inlets and one outlet. So this is also some is there, condenser is there, condenser coil is there here. This is all steady flow energy equations. Ma. They are having some boundaries. Ma. The stream flow is limited to this boundaries only. So this length width inside that only it should be having. So then it is called as steady flow energy equation. Otherwise it is called as non-steady flow energy equation. So this is a explanation for flow process and non-flow process. So I think I have covered the important and basics of this unit one, which will be helpful for you to update the knowledge in the thermodynamics. So I think you will get enough knowledge by seeing this video. Thank you, ma. Thank you very much.